Hi there, my name is Ron Pereira and I'd like to officially welcome you to this first overview module of the GEMBA Academy 7 QC Tools course. Well, by the end of this module, you'll know what quality control is, you'll understand the benefits of quality control, and you'll know what the 7 QC tools are. And you'll also begin to see how the 7 QC tools can help your organization improve no matter what type of work you do. To be sure, you don't have to manufacture widgets to practice quality control, as we'll learn throughout the rest of this course. Okay, well, let's get things started by offering a definition of quality control. And to do so, we're going to hear from one of the giants of quality control, Dr. Kaoru Ishikawa, the person credited with defining what we call the 7 QC tools today. Well, when asked to define what quality control was, Dr. Ishikawa said that it consists of developing, designing, producing, marketing, and servicing products and services with optimum cost effectiveness and usefulness which customers will purchase with satisfaction. Now, from this definition, it's clear that Dr. Ishikawa felt quality control was far more than visually inspecting parts at the end of the assembly line. In fact, Dr. Ishikawa often spoke of total quality control, or TQC, which saw quality control spread to all facets of the organization, including front office tasks. So that's what it is. Now let's turn our focus to the benefits of quality control. First, when quality control becomes a way of life, the number of defective products will decrease, and as such, over time, customer satisfaction will increase, leading to enhanced trust and loyalty. And from an internal perspective, consistent quality control lowers costs for the company since people aren't wasting time reworking parts and waiting for good parts to be produced, and as such, profits increase year over year. So, you see, done correctly, quality control reaches all aspects of our business, which results in happy and loyal customers. Now then, the tools most often used for problem solving by organizations well versed in quality control are called the 7 QC tools. Now, for the rest of this module, we'll take some time to introduce them, and then throughout the rest of this course, we're going to be taking a deep dive into each tool, explaining how they can be applied in both manufacturing and transactional environments. But before we get into the tools, I'd like to provide a little background on how these concepts developed. And as it turns out, the Japanese began applying quality control during the 1930s and 1940s after Dr. Walter Schuhart and Dr. W. Edwards Deming introduced the concepts. And Dr. Kaoru Ishikawa, the then head of the Japanese Union of Scientists and Engineers, decided to expand the use of these tools in the 1960s with the introduction of what we now call the 7 quality control tools. Now, Dr. Ishikawa chose these 7 tools as a way to make the use of quality control accessible to anyone, no matter their experience with statistics. Well, the first of the 7 QC tools is the graph. Now, most of us have seen or used graphs at one time or another. With graphs, data are expressed to easily compare quantities or quantity changes. They're also used for arranging data, sharing information with others, and making judgments. Now, in our next module, we'll not only explore several different types of graphs, but we'll also explain how to choose the correct graph to use. The second QC tool is a check sheet, which are tables used to arrange data by type. Now, we also use these simple but powerful tools for checking if jobs are completed without problems and for preventing mistakes from happening at all. The third QC tool is the Pareto chart. Now, Pareto chart classifies problems and defects by type in the order of quantities and shows a cumulative total. Now, Pareto charts are often used for checking a problem or defect to be highlighted for solution. In other words, Pareto charts often help us identify where the problem is, as we learned about in the GEMBA Academy Practical Problem Solving course. And as a reminder, Pareto charts get their name from Wilfredo Pareto, the Italian economist who was the first to identify the so-called 80-20 rule. Well, the fourth tool, invented by the aforementioned Dr. Ishikawa, is the cause and effect diagram, sometimes called the fishbone. Now, the cause and effect diagram systematically arranges the results of effects and the factors that influence them. With this information, we're able to classify causes and the potential influence on the problem at hand. The fifth QC tool is called the scatter diagram, which is a graph used to examine the correlation between variables by plotting corresponding data. In other words, scatter diagrams help us understand the relationships between two variables and whether or not they're associated or correlated with one another. Now, we'll get into different variations of the scatter diagram, including regression, later in the course, but I do want to mention an extremely important aspect of studying correlation. Namely, that correlation does not automatically mean there's causation. Now, an example of this is how in some cases it can be statistically shown that as the number of liquor stores in a town increases, so do the number of churches built. So one could conclude that if a town hoped to have more churches, all they need to do is build more liquor stores, right? Well, of course this is complete nonsense, since the two, liquor stores and churches, aren't correlated at all. Now, a better explanation for this situation is that as a town grows in population, there will be some who like to visit liquor stores and some who like to attend church. Next, we come to the histogram, which is a graphical display of numerical data in the form of upright bars. With histograms, we're able to learn many things, including how much variation or spread a data set contains. Now, when we add in customer specification limits, which we'll learn more about later in the course, we're able to calculate something called CP and CPK, which basically tells us how well our process meets customer requirements. And last, but certainly not least, we come to the control chart, which is a tool used for judging the situation of quality values against control limits in order to check the stability of a process. Now, control charts also help us to understand whether we're dealing with common cause or special cause variation, which is an extremely important information to know as we work to control quality across all levels of the organization. Now, we first learned about common cause and special cause variation in our practical problem solving course, but as a quick refresher, common cause variation could be likened to the normal everyday traffic we experience on our commute each day to work. And special cause variation could be likened to when there's an accident and traffic comes to a complete standstill. All right, well, those are the 7 QC tools. As promised, throughout the rest of this course, we're going to take a deep dive in each one separately, explaining how the tool can be applied in both manufacturing and transactional environments. Additionally, throughout the rest of this course, we're going to learn how to create each of these tools using Microsoft Excel and Sigma Excel statistical software. All right, well, this wraps up this overview module. In our next lesson, we're going to dive right into things as we gain a deeper understanding of the many different types of graphs available to us. So, we'll speak to you soon.